Good morning and afternoon, everyone. Welcome back to our Autodesk HSM Friday Fast Track Hangout. Today we have Scott Moyse and Gavin Bath with us today. They're going to go over some probing and tolerances. Welcome, Scott, and welcome, Gavin.
Hi, everybody.
Hi. Thanks for coming along.
Thanks for being on with us. And if you can give us a quick, brief overview of what we're going to look at today.
So we've got a little bit of, Gavin worked at came up with a workflow in Inventor a couple of years ago for setting tolerances on the model directly inside Inventor. And now we've got probing in Inventor HSM. It was a nice time to bring the two together, although obviously both features have been in the software for some time. So Gavin's going to go over some tolerances, and then I'm going to go over some probing tricks that we've come up with in the recent HFO event we did in Brisbane, Australia, and I'll show a little bit of Fusion as well at the end.
Oh, very awesome. I know this audience is really interested in learning more about probing and tolerances and how we work with it in HSM. So before we get into that, I'd like to talk a little bit more about our Fast Track program. If you haven't joined our Fast Track program, I highly recommend you do. Our schedule of seminars across the U.S., you'll be able to join those seminars, get hands-on training, get those parts off of your napkin sketch into CAD, into CAM really quickly, and those are hands-on seminars. Also, these webinars that we do each week, we have Wednesday webinars for those of you who are new to our integrated CAM interfaces, as well as these Friday webinars. So you'll have access to these as well, and you can see what's up and coming on the schedule. And also you'll get access to our Pluralsight training live and also recorded videos where you can follow along with an instructor. We have our expert elites who create classes, and you'll be able to download the parts and walk along with them. So part of our Fast Track leads us up into Autodesk University. So every year Autodesk puts on seminars and keynote speakers and hands-on training classes that you can join at the Venetian this year, November 14th through 16th. We had John Saunders from NYCCNC. He was there teaching people who have never created parts on a machine before to walk through how to do it in CAD and CAM and send the code to the machines. They were up and running in no time. So I highly recommend joining Autodesk University, and join up to our Fast Track leads you right up into Autodesk University. So that's our Fast Track program. I have a couple questions I'd like to ask real quick on a poll, if you wouldn't mind taking a few minutes to answer. The first one, we'd like to know, have you been to our Autodesk University? I really appreciate your taking the time to vote, whether you've been there before or if you're interested in going and what it's about. So it's good for us to know who in our audience, if you're new, or if you've been with us for quite some time and working with our interfaces, that you'd be part of that Autodesk University. So it looks like the polls are filling up. We really appreciate your taking this time to get this info back to us. All right, I'm going to close out the polls. Again, thanks for voting. And I'm going to share those polls with you. 43% who are too busy making chips fly, and that's awesome because you're using our software, you're out there making parts. And some of you, 31%, would love to. How do you get there? At the end of the webinar, or we will put up a link, and you can also do a search in Google to find out where you can sign up and register.
A quick comment on that, Wayne.
Sure.
For those that would love to get there, you've got a 2-week window right now to win a pass to get there. Curtis Chan on Instagram has got a nice Fusion CAM challenge going where we're looking to see how you hold parts. We know that a large part of the machining process is work holding. It was one of our past webinars, and this contest has to do with creative ways of work holding. One of the prizes is a trip to AU. Another one of the prizes is some stuff from Orange Vice. So a great way to get yourself to AU.
Very awesome. And some of the things that we see in Instagram, some of the amazing parts that you guys make every week or every day, we're seeing some interesting and really neat ways that you're holding those components, whether you're doing 3-axis or 5-axis, really amazing stuff. And that can win you just from your everyday work, and what you love to do is going to win you a trip to Autodesk University. So that's awesome. Thanks, Al.
And one more thing, because I see Seth commenting, he's one of our experts. If you have something you want to present, the call for presenters is gone. Autodesk University is very much about users teaching users, and that's another way to get yourself there, is share what you love and know and learn from others as well. So you can look at the call for presenters.
Absolutely. Okay, so let me hide that. I'm going to bring up another question. We do want to know what's most likely to help drive your growth. So as you're working with our interfaces, our integrated CAM, and working with your machines, where is it in your shop that you're looking to grow? Where can we help you grow? And this information, it's going to help with our developers who are going to know where you guys to get the most out of our software. And also it help us drive in the future webinars to bring more information on those aspects that will help you grow in your business. We're going to have more webinars and we're going to talk more about what's in development. So it looks like a lot of you are voting. We really appreciate that. Okay, we're getting a good percentage in. All right, I'm going to close out the votes. Thank you guys for voting. And let me share this with you. So it looks like we have a good percentage of you are looking into learning more about 2 and 3 axis milling. 22% are looking for more 4 or 5 axis positional. Okay, we appreciate this feedback, and this is going to help us when we go into the future driving more development in our software as well as more content that we can get out there for you to help drive your business. So let me close this out. And with that, I'm going to bring it over to Scott, who's going to talk more about the probing and tolerances, and he's going to work with Gavin. So Scott, are you ready? I'm going to hand it over to you.
If I may, Wayne, I'll just maybe jump in quickly and give a shameless plug for Scott and Gavin. If you don't know, Scott and Gavin are with one of our partners in Australia and New Zealand. They do a lot of great training for customers there, custom post-processor development. Very, very active in the community. And thank you on behalf of Autodesk for volunteering to do this webinar. I think you're a great example of an excellent partner.
Thanks, Al.
Yeah, cheers, Al.
All right, so there's 2 of us, so we get 2 slides at the beginning. So both of us are Autodesk Expert Elites and fulfill very similar roles at CADPRO. Gavin's just a bit smarter than me, that's all. So CADPRO have been an Autodesk partner for 25 years. It's a family-owned business, New Zealand-owned. We cover all of the different industries that Autodesk covers apart from media and entertainment. So across the team, it's a heavily technical focused team, and across the team there's more than 50 years of combined manufacturing experience. So just to talk a little bit about myself, that picture in the top right hand corner is actually a flag, not 4 separate places for a picture. It took a while for Gavin to figure that out, so maybe he's not as smart as I think he is. And that in the bottom right hand corner is a Cornish pasty. So yeah, I'm pretty proud to be a Cornishman, but I'm living on the opposite end of the world at the moment, that's for sure. So my background is I studied motorsport engineering at university in Wales, and then I moved to New Zealand in 2004 because my family had moved over here, and I got the opportunity to work for a world-class super yacht interiors company. So shortly after I joined there, they got a CNC machine, and I started programming that and driving the adoption of CNC through the company and working with the old boys in the shop and convincing them that the robot wasn't going to replace them, it's going to help them do their jobs and get a better product at the end. So it was a neat process to be a part of. And then 3.5 years ago, I moved over to start working for our CAD supplier, CADPRO. So just got a few pictures of some of the things I've got up to over the years. And there's a rather fresh, young-looking, skinny version of me in the red race suit there behind the first car I was involved in building at university. So CJ Abraham a few months back did a Friday webinar covering Formula SAE. So in Europe it's called Formula Student, and it's an excellent kind of program to be a part of. I learned so much from it. So this thing was a crazy little car, really. We ended up having it do 0 to 60 miles per hour in just under 3 seconds with all the restrictors taken off and uncut wet tires. It was pretty wild. And we used some interesting techniques on the car. So the crash structure on the front was actually made up of beer cans, Dutch beer cans, which Laurens would be quite pleased about, I'm sure. So, and it worked really well. And the engineering judges loved the the ingenuity involved in creating something like that. So then year 2 was kind of a step up in technology. It was a carbon fiber chassis with a steel exoskeleton roll cage around the outside of it. Now the chassis without the just the carbon chassis itself weighed 7 kgs. I don't know how many pounds that is off the top of my head. And with the steel roll cage, it was 27 kgs. All up, that car was just under 200 kgs weight. So it was an incredible car, really. So once I moved over to New Zealand, I started doing the super yacht stuff and got to work on some pretty incredible projects. And this is just a selection of my kind of favourite, 2 of my favourite boats I was involved with. This one was Black Pearl. Was first super yacht commissioned by an Australian owner, and they've been all over the world with it. They're really nice people, really engaged, and really appreciated the work that everyone put into it. And it was really neat to be a part of that. So, and then this is the kind of interior that was in it. It was quite modern and clean looking. And this stairwell was quite fun. There was actually 2 stairwells in the boat, and there wasn't enough space for a handrail, so we came up with this integrated handrail idea to meet class for the boat. And then this was a Chinese-built super yacht by an American-owned individual based out of Miami. It's called Nisi Yachts. It was pretty kind of fresh-looking boat as well. And yeah, it was fun to be a part of. I did some consulting for those guys up in Zhuhai, and yeah, so there's me. I'm pretending to pilot the yacht. Yeah, so we did designed all of that ourselves here in New Zealand. The whole concept we came up with, and made all the CNC machined all of the molds and shipped them up to China for them to then lay everything up. So over the years, I've used Inventor, Volt, and CAM. I've done quite a lot of work with Volt, same as Gavin, since 2012, I believe. So I've kind of I feel like I've got a pretty good handle on the overall process of how things are designed and manufactured. And then Scott and Gav After Hours is we've set up a company called ChipX, and we're importing kind of premium American-made products from the States and selling them here in Australia and New Zealand. So it's been going well for us, and it's neat to be able to deal with customers, not just from a software standpoint, but actually helping them make parts. So I think this is a point where I'll let Gavin, we'll switch over to Gavin there, Wayne, if you can kick over, and he can talk about himself.
Right, well thanks Scott for the generous introduction. I didn't expect you to say clever. I thought you'd say he's the shorter version of me, but that's okay. So yeah, interestingly, Scott and I have got fairly similar backgrounds in a way, and I guess that's probably why we get on so well. So yeah, CAD and CAM geeks at heart. I was born in South Africa. I've been in New Zealand most of my life. I started with mechanical engineering back in about 2000, and switched backwards and forwards between mechanical engineering and computer science. Always been quite interested in the programming world, but also design. I've been using Inventor since R4 and Volt since it was product stream for data management, and you know, since Autodesk took over the CAM, I've been involved with that. So I started that in the beta program when they launched that, and yeah, love all of those products. Spend a lot of time in them. My industry experience has been in a few industries, including some aerospace and defense stuff, and some materials handling work, and then other bits and pieces as well. So I've been with CADPRO for 6 years now. Great place to work. They give us a lot of freedom to explore all sorts of areas that we want to, and that kind of nurtures the, I suppose, natural interest we have in the products that Autodesk produce, and so we get our teeth stuck into all sorts of things. In my spare time, I take my coffee very seriously. I do a bit of CNC in my garage. I've got a little mill that I converted to CNC, and a bit of other stuff with flying. So I'm a recovering petrol head. There's been a few things that I've been involved in before. Well, back when I had time. So building cars and even machining bits and pieces for engines and suspension, racing karts and riding bikes. This is where I started off. Well, I was actually still at university at the time when a friend of mine was working for a little startup in New Zealand making ground support equipment for airports, and they were growing very quickly. He was stuck. He knew what I knew and said, come and work for me. So I joined their team, and that was my first design job, and I got into designing all sorts of gear for airports all over the world, and the company grew very rapidly. We developed a huge range of products in a very short space of time. So from a building experience point of view, as a young designer, it was a fantastic opportunity. Unfortunately, the directors were, I shouldn't go into detail, but didn't do a great job of managing the growth, and the company unfortunately fell apart. I didn't really like that feeling that, it was something out of my control and I no longer had a job, so I decided to go off contracting. So that was about 5 years in ground support, and then I basically just went into contract design and mechanical design and drafting for a range of customers in New Zealand and Australia. I ended up joining one of my customers in a business venture. He had a little defense manufacturing company, but he was outsourcing everything, and he wanted to bring manufacturing in-house. So he asked me whether I'd be interested in sort of taking shares in the business and developing a manufacturing arm. So we got into that, and we manufactured electronics enclosures mainly, and instrument panels for a variety of customers, including Boeing. We got on their approved suppliers list, and that was probably what I'd consider one of my favourite achievements. I got to go over to Boeing and have a bit of a tour of the 787 facility when it was in prototype stage. So a lot of fun. Learned sort of a little bit about the defence and aerospace industry and how it works, and that's when I really got into machining in a big way. We had some machines, and for a couple of years I spent a lot of time running them. We had a little bit of an earthquake in Christchurch, which you might have heard of on the news. That was the picture on the right, was our house shortly after the waters subsided. I don't know if you can see the mark on the wall where what the water came up to, and unfortunately that flooded the house. So that kind of put a stop to my contracting business. I just started a 3-month contract the day that happened, and so I had to ring and cancel that. Luckily they were understanding, and so I went and knocked on CADPRO's door. They'd been a supplier of mine for about 10 years, so they knew me well, and thankfully they took me on board, and I got into the Autodesk channel and sort of started to learn a bit about how that worked. So for the last 6 years I've been doing technical support, consulting and development work for them, primarily with Inventor, Volt, and HSM, but obviously the Fusion 360 product is something that I get really excited about, and I've fairly recently started a Fusion 360 meetup in Christchurch. So we get together once a month and design and make things using Fusion 360. So that's enough about me. I'm going to dive into the technical stuff now, and start to talk about this tolerancing stuff.
So just one quick thing here.
Sure.
and this intro ran a little longer than normal, but I think it's good to have our community understand the talent with the Autodesk partners in the CAM space. There's a lot of customization, a lot of things where your local partner is going to be a great resource for you. So thanks, guys, for sort of explaining your backgrounds and presenting what all of our partners are like. I don't think you guys are unique. You're a good example of the partner network.
Okay, great. And I must say, it's great to work with other people with interesting backgrounds, and I guess it's the variety that keeps everything exciting. So yeah, we really enjoy that Insta-Machinist community on Instagram and the things that we see and discuss on there. So if you're not on there, get on there. All right, so I'm going to put the design and CAD hat on for today. And I'm sure most of you are have a very deep understanding of fitting and tolerancing, because you probably work with these concepts every day. And I'm not going to bore you with a slideshow of doom. There's really, a couple of slides and then we get into the live stuff. But I just thought I'd go through a quick primer, or, a bit of a recap of exactly what this sort of tolerance, limits, fits type stuff is about. So when I was learning this stuff 15 years ago, we all referred to the same book for this handy table that you can see on the right, called, the book was called Engineering Drawing by A.W. Boundy. But I'm sure you guys in the US are either using Machinery's Handbook, or you probably have your own version of this, in your own units. I can't remember what units you use over there, something like oranges per fortnight or something along those lines, isn't it?
We don't know what a fortnight is over here. I know you guys are up early to do this, but we're not talking about fortnights.
Okay, so Machinery's Handbook is probably the common one, but essentially, most times we're talking about something, we're referring to something by its basic size. So we're talking about a 20 millimeter diameter hole or a 1-inch hole. Now, in practice, that's not going to be exactly 1 inch most of the time, or exactly 20 millimeters, because of obviously machine inaccuracy and also design intent. We need to be somewhere near that number, but not exact. So if we want a press fit, we're going to have one size. If we want a loose fit, we're going to have a totally different size. So the way we kind of keep those controlled and govern them is by using limits and fits. So the basic size is really the size about which those limits are fixed, and we sometimes also call this the nominal size. And then the limits are the two extremes that are allowed for that dimension. So if it's a 1-inch hole, actually I'm not going to talk in inches, sorry, because I'll say the wrong thing. If we're talking metric, if it's a 20 millimeter hole, we might have a plus or minus 0.1 of a millimeter tolerance. So we'd be happy with a part that was machined anywhere from 19.9 millimeters diameter to 20.1 millimeters diameter. Then a fit is the relative motion that can exist between a shaft and a hole, and I use the terms shaft and hole loosely here because they don't have to be necessarily two round parts, but it's effectively whether there's a gap or whether there's an interference between how those parts fit together. The tolerance is basically just the difference between those maximum and minimum limits. So when I talked about the plus or minus 0.1 of a millimeter, that's really a 0.2 tolerance on the hole centered around the nominal. And then the deviation is the difference between that nominal size or the basic size and what we actually end up with off the machine. So if there are any questions on that, now might be a good time. Otherwise, if that's all, if everyone's happy with that, we'll carry on. Okay, we'll carry on.
I'm not seeing any questions, so I think you're doing okay.
Okay. So I think the easiest thing to do now is to just jump into Inventor and see what that looks like in practice. So I'm hoping that the switch is going to work, and hopefully you guys will see the model on my screen now.
That looks good here.
Okay.
I don't know what it's like for other people. There's a little bit of a lag on the video. It's coming all the way from New Zealand, so just be aware of that. Don't make any sudden changes with your...
I should just check, Al, is the video coming in upside down for you guys?
No, but if you spin clockwise on your end, I think it spins counterclockwise on ours.
Right, good to know. Okay, so I'm not going to get into the cam stuff. Obviously, that's what Scott's doing here. But just very briefly, if you haven't seen this before, we've got a configurable vise here, which allows us to manipulate our work holding. So you can see I can do things like change the types of jaws I'm using in my Carve Smart system here, and I can change the jaw openings, whether it's a single or double station vise. I've got a flexible work holding system here. So if you're interested in that, I'm really hoping my Autodesk University class gets accepted, and if you come to AU, you'll be able to see that in detail later in the year. But what I'm going to do for now, because but what I'm going to do now is, because I'm the CAD guy today, I'm just going to open the part and talk about just the part. So I'll let this settle down now. So you should be able to see that we have a representative hole in the middle here, a bore, and for this discussion, we're only concerned with the tolerance on the diameter of that bore. We're not looking at any of the other features on this part today. So in Inventor, or actually SolidWorks or Fusion for that matter, the dimensions that control the features on your model are controlled by things called parameters. And parameters are basically a number that can be changed at any time. So here you can see that I've got a dimension on the sketched circle that controls that bore diameter, and you can see that it has a range between 30.04 and 30.06. That was originally placed as a dimension on the sketch, and then I typed in the nominal diameter of 30 millimeters. And there are a number of advanced users in our customer base that still haven't used the tolerance feature on that dimension, because a lot of designers just work on nominal. They model everything nominal, and then in the drawings, when they do 2D drawings, they put tolerance notes on dimensions. But if you haven't seen it, the thing we're getting at today is that you can actually tolerance the model. So by clicking on that tolerance box there, it brings up a little tolerance window. And what this allows me to do is basically set limits or fits. If I pick fits, then I can choose from the common fit codes from that table in the book that I mentioned before. But in this case, I've just got limits stacked. I've just got a simple tolerance here, which is 30.06, 30.04. So in this case, my lower limit is 04 over the nominal size, and my upper limit is 06 over the nominal size, which is, a perfectly legitimate tolerance. They don't always end up that way, of course. You might have a minus and a plus for your upper and lower limits, but the point is we're telling the model that this is our allowed range for that value. So being a number, the model obviously can't show two values at once. So that's what this little evaluated size control in the top right corner does. If I click on plus, what that'll do is it'll actually change the model value to the upper limit. And if I click on minus, it'll change the model limit to the lower limit. We have nominal as well, so in this case that would be 30 millimeters, or we can go median, which will be right in the middle of the two limits. So if I just get out of there and finish the sketch and we look at that hole, if I measure that hole, you'll see that it's currently measuring up at 30.05 millimeters. So that's halfway between our two tolerance values. I can, however, now that that's defined, at any stage open up my parameters dialog, and that's this little FX button on the toolbar, and I can go and find that parameter. You can see here I've pre-named it bore diameter so that I can find it easily in future, and I can change which of my limits the model represents. So if I change this to nominal and click done and use the measure tool, you'll see that that's now 30 millimeters. So what that means now is that because the model is driving the CAM engine, we can actually start to control what our CNC machine is targeting based on, excuse me, sorry. Just set that back to median. We can now start to control what the CNC machine is shooting for by changing the tolerancing in the model. So I'm just going to jump back to my slide deck now. So just to recap, the process is you create the dimension, you put a tolerance on it, you set that tolerance to whatever your design intent is, and then you can adjust it later by using those little controls in the parameters window. So that gives you a few options as to where you shoot. If you're machining and it's coming out undersized, you can go and shoot for the top limit. You're probably going to then end up in your range. If you machine the part, it comes out oversized. For your second off, you can hit the minimum limit. But most times, if we aim for the median, hopefully we'll be somewhere in the right range. Whereas obviously, if this was just a nominal size and the limits mean that I have to be over, we'll never actually get there without applying some kind of compensation downstream.
I think it's a good thing to point out, because there's a lot of times where people are toolpathing directly off the model, and it's a common practice for CAD designers to just dimension to nominal. So even though a board might have a +5, -0 tolerance, then you don't. Your toolpath from the very beginning doesn't take that tolerance into account, doesn't give you that tolerance, and you actually machine your part. So I'm glad you showed this and how you can put the model at the center of tolerance so that when you're machining the part, you have that full tolerance to work with. It's a good thing to be aware of as people do more and more machining directly on the model, thinking about how that geometry is defined.
That's well summed up there, Al. And I mean, I think this is part of a bigger thing, which is, you know, the term would be design for manufacturing. My industry background's always been in manufacturing, and I've always been really interested in the flow of information from the model to the actual part. And I mean, that covers all sorts of things, from sheet metal and things like K-factors for folding right through to things like this with machining. But essentially, we want that digital model to represent the real thing as closely as possible, and that's what this is about. So that.
Yeah, and this is Tim. We had a question while you're on your slides. If you can reiterate the name of the book. Somebody is asking the name of the book that you mentioned.
Oh, sure. I think I might have that in a link in the end, but
awesome. We'll just leave it at that.
I could be wrong on that. Let's talk about that. There's a reference slide right at the end with some links on it. One of those links is a blog post that basically covers the whole CAD side of this process. So everything I'm talking about today is covered in more detail in that blog post, and in there's a direct link to that book on Amazon. So perfect. Just bear in mind that that's not a machining book. That's a book about engineering drawing, and it's sort of focused on our region, Australia and New Zealand. So I think Machinery's Handbook is probably a better reference for anyone outside of that region. But yeah, that book's in there.
Perfect. Thank you.
Okay, so you got some options about how to use that. You can either machine your first off, measure it, adjust the model using those controls I showed you, and then machine your second off, and hopefully it'll be in spec. The second option is to use in-cycle probing to kind of let the machine do that itself, and that's the magic that Scott's going to show you shortly. So in testing this at one of the events we did recently with one of our customers down here that's got a UMC 750, with this part, you know, after the first pass, the diameter was sitting at 30.036, which is about exactly 0.004 millimeters below the target. I think that's 1.6 tenths, as you guys would call it. As a tenth is a 10,000th of an inch. Is that right? I guess.
Correct. Yeah. Yeah.
Okay,
100
right.
millionths or 1/10,000th of an inch. Yeah.
It's
Okay.
funny you say that. I was writing a newsletter today with some machining lingo to make sure all of our Autodeskers talk correctly, and saying what a tenth is one of the things in that list.
Okay, great. I'll look out for that, because that's confusing for us, because a tenth tends to be a tenth of a millimeter here, but we don't really use that term anyway. So okay, so we ended up at 0.004 below the lower limit, which obviously puts the part out of spec, but that's also 0.014 below our target, which was the median. So after the stuff that Scott's going to show you, the finished pass was 30.049, which put it 0.001 under the median limit, which was our target. So I mean, I guess we took that as verification that in a way that what we were doing was working, but I should use a disclaimer here that our testing wasn't very thorough. We only measured the first part, and you know, we weren't using the best measuring equipment either, so you know, it was illustrating a concept, but at least it seemed to work. So I'll let you guys go off and experiment and tell us whether you know, whether you find use for this. Okay, so that's me. I'm going to leave it there and hand it back to my fellow esteemed member of the Precision Machinists Guild of Down Under. Actually, I just made that up, but I'm going to pass it back to Scott. Thanks for listening.
Thanks, Gav. This bit was, can you see my screen now, guys?
Now we can.
Yep.
All right. So this bit was a little bit unplanned, but I just wanted to point out, and I'm actually quite keen to find out whether any of you guys can tell us whether this is possible or not. I couldn't see whether it is, but in SolidWorks, when you edit the sketch and highlight one of the dimensions here, you've got the ability to set the tolerance and precision for that sketch dimension in a very similar way to what Gavin just showed inside Inventor. But the key step I'm missing here is how to get it to actually apply to the model. It looks like I've read some stuff online. It looks like there are some kind of tricks you can apply with some automation to get it to work. But if there's a simpler way to do it, then I'd love to know what it is.
You know what? I think I can confidently say there's not a simple way to do it. All that's really going to do is pass the text to the drawing when you create the drawing. But
yeah, okay.
I'll second
that. What I love about the Inventor approach is that that information can be pulled through from into the drawing as well, and then the machinist can turn on and apply it to the model as and when they need to. And the CAD model, when the CAD guys are using it and specifying tolerances, can stay nominal.
Yeah, that's wonderful. Yeah.
Yeah. On the Fusion side of things, the best I could come up with at the moment was creating a series of parameters, upper, lower, and median. And so I've got this sketch. If I edit this, I can see that the bore's specified as 30 mil. There's no tolerance option in here yet. I've named my feature. So walls, and the way that the parameters are organized in Fusion is quite nice. We can see that under sketch 1 I've got the bore parameter of 30 mils, and I can come in here and just add the median parameter, and it will modify to bring it within spec, which will then change my model. But that's the best I've found so far. I tried to get some direct editing workflows going, but they don't quite work. So that's the most reliable way I've found of replicating similar behavior to Inventor. But I'm going to get on with my section of the presentation now. So the part that Gavin's was showing, we've made a few of them now, both in Australia and New Zealand. This video might be a bit jumpy. We've got a YouTube link that the guys can share if this is too jumpy, but this is a UMC 750 down in Christchurch, Sprint CNC's machine that they've recently got back in early February. So we've gone through and finished the bore, And then I used a through spindle coolant option Swift carb to blow air through to clean the bore out, because we didn't have a Lang fan or anything like that, to make sure there was no excess coolant or chips sitting in the pocket. And then we're just using a normal probing cycle that generated from Inventor with a little bit of a post tweak. It's just measured the bore and it's passed back the difference between what the target is and what the actual is, and modified the wear offset in the tool table, picked up the same tool again, and it's coming back and remachining that bore back into spec. So how do you go about enabling CMM probing in Fusion or HSM? So currently the way that the probing cycles are set up is mainly for setting your coordinate systems, but the difference between a probing cycle for that and the Renishore cycle for that and CMM is very, very little. So all we wanted to do was find a property to use that we could mark a probing cycle as a CMM. There's a number of different ways you can do that. You can use manual NC. You can use the notes or the notes feature against each individual operation. I'll show you that shortly. Or the operation comment, which is the name of the toolpath. Definitely got to read through the Renishore programming manual and understand what options are available and all of the different parameters that you can apply to these different cycles to get different behaviors. You're going to have to edit your post and have an understanding of wear compensation and how that works in the CAM system and relates to your machine. What we find is lots of people don't understand that and don't use that option, so it's quite a good one to have. It's a nice compromise between in-computer and in-control compensation. So I'll just jump into Inventor now and show you how it's set up. So aside from all of the other toolpaths that lead up to getting close to the feature we're going to be probing, we've just got a normal 2D contour for finishing that wall. And then the remove coolant version of that toolpath is just another 2D contour with the height set differently. These new browser tabs in 2018 are awesome, by the way. I'm totally in love with them.
Sorry, Scott, I'll just mention you might just need to slow down the motion a little bit. It's just a little bit jumpy over here.
Okay, thanks. So we just got I've just set the bottom height to stock top and 25 mils above that. So and changed the coolant type to air through. And
so I'm curious for just some feedback from others on the line. I found that a very creative solution to use a through spindle air to blow off the part. I'd love to see some comments on other unique ways of blowing off the part and getting coolant off the part in the comments.
Cool. Gavin actually wrote a little tilt routine, so that I think if we post process here for the UMC 750, it's got a B-axis tip. So at certain points in the program, it will actually roll the part over and empty it out. So if you've got a 5-axis, you've got that luxury. All right. So then the next step here is one of the interesting things about the probing cycles on the Haas. Is that every time it runs, it adds the value to the wear offset. So the more you run, the more accurate it gets. So the first cut is, well, actually, so it depends on how you run, whether you're running wear comp on your first operation or not. But if you are, then it keeps getting more accurate. If you're not, then you keep going, it keeps adding this wear compensation value and stacking it up. So you need to make sure that you clear it out and reset it to 0 in that case, and that's the safest approach to take anyway. So you can, and it's probably, I'm not too sure about on the FANUC controls, but on the Haas controls you can reset the wear compensation offset using parameter 26, and then the last 2 digits is the tool number, and then make it equal to 0. So Gavin came up with the idea of using a pass-through here and then just typing in that value. We could actually control what these 2 values were based on the previous tool if we wanted to in the post. And so that's going to reset every time that wear value for that tool prior to doing the probing. When it comes to doing the probing cycle itself, It's just like a normal WCS probe. You pick your tool, pick that face, and we don't want, it's just a normal circular hole, and that's it. That's all there is to it for applying the toolpath. And then in our case, we chose to use the notes and just add the tag CMM, and that's all that's required to switch between a WCS probe and a CMM probe. And then we come back, pick up exactly the same tool as before, and remachine the bore. I don't know if just kind of like a quick free tip. I don't know how many of you have used this before, but you can actually right-click on any of these toolpaths and select optional. And when you do that, it adds this little / in front of the operation. Now what that does is it turns on, it starts, as long as your post supports it, when you post the code out, you end up with block delete lines in front of every single block. So you can choose to either run this set of toolpaths or not on the fly at the control. So so I've covered that. And
there's a quick comment here that I think I'll address. It's actually from our intern Xander, and he's asking how do you respond to a question of how accurate is the machine at checking itself. So I think it's good to clarify. Obviously, if the machine doesn't know what an inch is and it's out of calibration, then even probing is not going to help anything. What probing is going to catch is if the tool isn't cutting the size it needs to be because it's not in the holder perfectly, or it's cutting slightly undersized or slightly oversized, or if there's some deflection, you're going to capture that. But naturally, you can't measure with the same tool it's cutting and expect that somehow it's more accurate in its positioning with a probe versus a tool. What this is going to do is catch inaccuracies in the tool or deflection or something like that.
I'll jump in and say that there's definitely the question of measuring it with the tool that you made it with, and there's no replacement for offline inspection, but you can mitigate some. I've worked in a AS9100 shop, and we were able to show our calibration routines and our checks, and we kind of had logs of checking the accuracy of the machine, and that satisfied most of the AS9100 issues that we had. So
it's worth mentioning that we calibrated the Renishaw system before doing this, and that tolerance, I guess, compared to what some of you guys might work to, that tolerance of what was it, 0.02 of a mil, was fairly coarse. So in that kind of range, this was perfectly acceptable. If you're down to the thousandth of a millimeter, then you might have to rethink things. But
yeah, we were able to pretty consistently show that we had a Haas VM3 at L3 Communications. We were pretty consistently able to show that it measured within a couple 2 or 3 ten thousandths of an inch. So
nice.
That was more than enough for what we were trying to do, and because of our documentation, we were able to include that as part of our inspection process on some features. So
okay, I'll just quickly go over the changes we made in the post to get this to work. We noticed that when we first started doing this, we were getting errors at the control after the probing cycle had run, saying that the next feed rate was too high, was exceeding the maximum feed rate of the machine. And we discovered that there must be something not quite right with the probing. Man, this happened on 2 different machines now. The probing macro in the Haas control. That means it ends up in some other feed mode, so you have to switch back to feed per minute after you run the cycle. So the first step really was to kind of capture the state that the probing's in. So whether you're in whether you're in the mode for setting your coordinate system up, or whether you're in CMM mode. So created a variable called probe CMM and gave it this property of enabled, and initially set it to false. So from there, we then look at trying to capture that. So if I search through for CMM, and we look for on parameter. So if there's a parameter with a name of notes and a value of CMM, then enable the probe CMM property to true. If it isn't, then set it to false. So once we've got that set up and the post runs down to actually generate the code for the probing, that happens in on-cycle point. And we come down and we look for the particular probing cycle we're using, and in this case it's circular hole. Yeah, it's an XY circular hole. And there's two cases in here. So if probe CMM is false, then do the normal one. Okay. And so with the normal probing cycle, we have D, Q, and S added after the 9814 macro call. But if it's true, then we collect the previous tool number from the previous section, and then we get the next tool number and do a comparison. And if they're not the same, it throws an error. So you want to make sure that you're applying the compensation offset to the tool you machined with, and then you're remachining that feature with exactly the same tool. So if you're not, then this workflow's not going to work. So I've got that check in there.
I want to be careful how I do this, but I think it's important. Many people on these webinars may feel the need to do post edits themselves, and obviously the posts are open and anybody is allowed to. At the same time, most machinists run their business making parts, and so I can't strongly enough suggest working with one of these partners. Yes, they're going to charge you for their services, but there's a lot of customization and automation that can be done with the post-processor system, and it's a great way to sort of build a relationship with partners, again, like these guys. Again, I want to be careful sort of too aggressively promoting partners like CADPRO, but you've taken the time to get on here, and you are experts that I know add value to our customers.
Thanks, Al. Yeah, the really cool thing about this post system is because it's built on JavaScript, there's so much stuff you can do with it. So I wouldn't quite go as far as saying the sky's the limit, but yeah, if you apply some imagination with some skills, you can do some pretty cool stuff. And then, of course, put your machine into single block mode the first time you run through to make sure you don't crash your machine and get your distance to go screen up. So the only difference here between this cycle and the previous one is that we're still using the D value, but the function of the D value changes slightly, and then the T value, which is basically telling the control which tool or where offset to put the differential value into. Just keep a track on the time. So you can get access to the Inspection Plus manual on the Haas website, and there's a whole bunch of stuff in here. Like you can even, we were discussing last night about some different methods. You can actually determine the distance between two Z-planes. So if we wanted to, we could probe this space here and then probe the bottom of the bore and check that the depth of that bore is in spec. And you just use two probing cycles and then compare the two to one another. So that's really all that it takes. Now, the other thing that Gavin did was pass through. On pass through, basically this isn't in all of the posts, but if you add on pass through in there, then you can do some extra stuff. So that's where, when we post this code out, we can see we've got our bore finish, and then we remove the coolant. You can see those block optional, the block delete forward slashes appearing in there. Then we get down to here, so here's the parameter where it's resetting the wear compensation to 0. We pick that tool back up, and then we can see in here that this is what's neat about the way that inventors modified the model. So instead of it being the nominal diameter value, it's actually picking up on that that median value that Gavin set in the model. So now it's telling the the probing cycle that the bore should be 30.05, and it compares that against what it measures and sends that value off to the wear offset for tool 14. Then we pick up the tool, come back and remachine the bore. And I think that is it. All right, so that's, I mean, you can go through and do all of the different types of probing cycles, but that's just what we've got to show for you guys today. So this is the reference slide that Gavin was talking about. There's not as many posts appearing on designermotion.net as there used to be. We've all kind of got far too busy, but we'll see. Hopefully we can get some more posts getting up there again over the next year. Michael Thomas still posts as often as he can on there, so it's still live. But there's lots of old good content on there that we've shared over the years, and this limits and fits post that Gavin wrote is a great example. And yeah, shameless plug for CADPRO. We are doing posts for people in the States as well. So if you do need any post development, then please let us know. We also support people in the States as well. And there's a link to the Rentio programming manual. And both of our tags on Instagram. We're also both on Twitter as well. So yeah. All right. So thanks a lot, guys, for having us on. And I think I've just managed to squeak it in under the hour.
Yeah, thanks everybody. Thanks for listening.
Yeah, thanks for everything you guys do for the community. I'll jump in and say that you guys are the perfect example of what we need our partners for. Often as Autodesk, we try to generally just support the functionality that we have inside HSM now. But you guys are pros at kind of pushing those boundaries as we push our developers. So good job today. Thank you.
Thanks.
Thank you, Scott. Thanks, Gavin. We appreciate your coming on with us. It's really great information. And guys out there, you can find Scott and Gavin in our forums. There are expert elites. Any questions you see that you can find and do a search for in our forums are there to help. They check every day and provide a lot of great information to help you guys as you're working through our integrated CAM. So Scott, Gavin, thank you again so much for joining us today.
No problem. It's been fun. Thanks.
Yeah.
All right, guys. With that, it looks like we don't have any more questions. We're going to close out. Again, thanks for joining us today on our Fast Track Friday Hangout. And we'll be here next week. Next week, we have Sunny McCullough. And she's going to talk to us about her background in education and what drives her passion for machining. So tune in next week. We actually have a new link, so please, if you registered, please re-register to see Sunny's presentation next week.
Wait a second. Did we not adjust it an hour later starting next week?
Guys, I apologize. You're correct. Thank you, Al. So we are starting an hour later. 11 o'clock Eastern or Western time, or Pacific time, and 2 o'clock p.m. on the East Coast. So hopefully you can join us an hour later. We feel that it's going to be a good adjustment to help a lot of people around the lunchtime to be able to join us. And hope also our teams in overseas and in Europe to give them a little bit more of an adjustment to join in. So again,
finish their meals before they join. So yeah. Thank you.
Absolutely. So please re-register if you're registering for next week. Again, we're starting at an hour later, and a new link that you can join. All right. So thanks.
So we need to get up at 5 next time, Gav.
That's right.
Yeah, it's only 5 a.m. now.
All right. Thanks, guys.
Yep. Have a great week.
See you guys.
See you now. Thanks, everyone. Bye now.